See guys, today I would like to discuss that grouping of cells. See, first of all, we have to know that what is cell. Cell is an electrical device which converts the chemical energy into electrical energy, hence which provides the electrical current in the circuit. The circuit symbol for the cell, as I said, that this is the circuit symbol for the cell. So in the circuit, whenever using that, this cell, in place of that, this is the symbol for the circuit. See, one is two vertical bars are there. Among these two vertical bar, one is big, another is the small. Big is meant for the positive, small is meant for the negative. This is the circuit symbol for the cell. Now, so how we can combine the cells and that grouping of types of grouping of cells or grouping of cells. Cells can be grouped into three types. First one is the series grouping of cells. Second one is the parallel grouping of cells. Third one is the series parallel grouping of cells. It is also referred as the what? Multiple arc. Now let us see the question like that. How to recognize the series parallel grouping of cells? How to recognize the multiple arc. However, multiple arc is not prescribed in the syllabus, need not to worry about it. So only you have to concentrate only on the series grouping of cells and parallel grouping of cells. See, as I said it, the basic purpose behind the grouping of cells is to, by using minimum number of cells, so you can get the required amount of current. I mean that by changing the fashion of connections, you can increase or decrease current in the circuit. So with this intention, we can group with this purpose, we can connect the circuit into, we can group the cells into three types. First one is the series grouping of cells, as I said. Second one is the parallel grouping of cells, and third one is the series parallel grouping of cells. That is nothing but the multiple arc. That is not prescribed for syllabus. Therefore, no need to worry about it. Then question is that how to differentiate, how to recognize whether the given connection is a series grouping of cells or whether the given connection is a given connection is a parallel grouping of cells. Now, on the basis of the definition, we can differentiate between the series and parallel grouping of cells. See, here in series grouping, let us see, today we are discussing about the series grouping of cells. While discussing about the series grouping of cells, you have seen that there are two cells are there. There are two cells we are considered. First cell, its EMF is E1 and its internal resistance is R1. Second cell, its EMF is E2 and internal resistance is R2. You see that the positive terminal of the second cell, it is connected with the negative terminal of the first cell. If three cells are there, the positive terminal of the third cell, if it is connected with the negative terminal of the second cell. Like this, positive to negative, positive to negative. If you are connecting like this only, or n number, say suppose you are having n number of cells, positive to negative, like this, if you connected that, so that direction of EMF is going to acting only one direction. Such a grouping of cell is known as the series grouping of cells. What it is? As I said that positive to negative, positive to negative. I mean that end to end, positive end of the second cell, it is connected with the negative end of the first cell. Similarly, positive end of the third cell, it is connected negative end of the second cell. Like this, you want to connect that, the EMF will go to act in one direction. Such a grouping of cell is known as the series grouping of cell. Then question is that what is the parallel grouping of cells? As I said that So here also you can consider more than two or more cells. You can arrange either in series or in parallel. Is it? If you arrange in series, what will get it? If you arrange in parallel, what will get it? If you connect that, if two cells, see two identical cells are there. If two identical cells you will connect it in series, you will get the large amount of current. Is it? If two identical cells, if you connected in parallel, you are going to get the decrease in the current. I mean that by using same number of cells, you can increase or decrease the current in the circuit. With this intention, we are grouping the cells into two types. So now I would like to discuss that series grouping of cells. As I said that what is the series grouping of cells? Now, what is the purpose behind this theory? The purpose behind theory is to obtain the equivalent EMF of the EMF of the cells. What is an equivalent EMF? As I said that equivalent EMF is the EMF of the single cell which produces the same effect as that of the combination of cells. Or equivalent EMF is equal to sum of the EMF of the individual cells. If there are three cells are there, is it? EMF of the individual cell you have to go on add it, which is equal to net EMF or equivalent EMF of the three cells. So here the purpose of this theory to obtain the equivalent EMF of the cells when they are connected in series. Is it? So first of all, we have drawn the circuit for this. As I said, the circuit symbol for the first cell is its internal resistance is R1, its EMF is E1. Similarly, you are connected second cell, that is its EMF is E2 and internal resistance R2. As I said that positive of the second cell is connected to first cell. So that direction of current is going to acting in the same direction. Therefore, this is the series grouping of cells. So I can remove these two cells. I can connect the single cell. By connecting the single cell, if I am getting same amount of current as the combination of cells, is it? So this cell, single cell, we are calling that equivalent cell. The EMF of this cell is equivalent EMF of the these two cells. You see. So now let us see. First of all, so in order to obtain expression for the equivalent EMF when two cells are connected in series, what you have to do that? First step you have to find the potential difference across the first terminals of the you have to find the potential difference across the ends of the first cell, that is first cell, that is VAB. These are the two ends of the first cell. That is potential at A is VA and potential at B is VB. So this is what the potential difference. As you know, the expression for this, that is potential difference between AB point is equal to E1 minus I1 R1. I minus R1. So you can call that equation 1. Similarly, you have to find the potential difference across the terminals of the second cell. These are the terminals of the second cell. You have to find the potential difference across the terminals of the second cell. So in the similar fashion, so that is VBC, which is equal to potential at B point VB, potential at C point is VC, which is equal to E2 minus I R2, because current is same. So therefore, I can write it as equation 2. So now third step is that potential across the terminals of the combination of two cells, that is across the AC, which is equal to, we can write it as that is VAB plus VBC. So expression from equation 1 and 2. What is that potential difference between AB, that is in terms of EMF, that is E1 minus IR1, since the plus sign there, therefore here written plus, that is E2 minus IR2, is it? So you can call from equation 1 and 2. So on separating variables, we get it is E1 plus E2. So we can take minus R1 plus R2. So you can write it as, this is VAC. So this we can call equation 3. Now as I said that equivalent EMF of two cells, it is a single cell which replaces the combination of cells and produces same effect as that of the combination of cell. And that instead of two cells, by using two cells, say if you are drawing that 5 ampere of current, by connecting a single cell, suppose you are able to get 5 ampere of current itself, then this cell we are calling that equivalent EMF of the equivalent cell, which is equivalent to what? Two cell, E1 and E2, is it? So now for this equivalent circuit, you have to find the potential difference across the combination of potential difference PD across the, you have to find the potential difference across PD across the terminals of equivalent cell. If PD across the terminals of equivalent cell is, that is VAC, which is equal to EMF. EMF is how much? That is equivalent EMF minus current is I. The resistance is here R equivalent. So this we can call the equation 4. From equation 3 and 4, you see that this is the equation 3 and this is our equation 4. Whenever that left hand sides are same, we can equate the right hand side. Therefore, we can say that from equation 3 and 4, we can write it as E equivalent minus I R equivalent So as you know, as you can write it directly instead of writing this. So E equivalent is equal to sum of individual EMF. Individual EMF of cell is E1 and EMF of second cell is E2. Similarly, equivalent internal resistance, that is R equivalent, is equal to what is from this expression, that is sum of R1 and R2. Say if there are 3 cells are there, so I have to just add the EMF of the third cell in order to get the equivalent EMF of the 3 cells when they are connected in series. So similarly, internal resistance, equivalent internal resistance, which is equal to R1 plus R2 plus R3. If there are 3 cells are there. If there are n number of cells are there, if it is the case, so what is the fate of the expression for the equivalent EMF is it? So for n number of cells, equivalent EMF for n number of cells, equivalent EMF for n cells, which is equal to, we can write as E equivalent E1 plus E2 plus En. Similarly, equivalent internal resistance for n cell. So which is equal to R equivalent to is equal to R1 plus R2 plus R like this. You can get an expression for. So the summary of this is that the equivalent EMF of a single cell, which is equal to sum of the EMF of the individual cells. If there are 5 cells are there, so each cell having certain EMF value, you have to add that. Say for example, everyday cell is there. For each everyday cell EMF is 1.5. So you have to add the EMF of 5 cell, that is it is 7.5 volt. Is it? So this is the equivalent EMF of the these cells. So as I said that 5 cells, if they are connected in series, you will get the total EMF, I mean the equivalent EMF of 5 cells, which is equal to, as I said, that 7.5 volt. So corresponding to that, internal resistance is also increases, because R1 plus R2 plus R3 like this. There are R5 each cell having some internal resistance. Internal resistance is also goes on increases. So once again, there are 3 basic steps are there. First, what you have to that abstract of this this theory is that first you have to find the first step. You have to find the potential difference across the terminals of the first cell. So you have to get an expression for one. Similarly, you have to find the expression for the potential difference across the second cell. That is, you are already familiar that you can call the equation 2. Now, potential difference across the combination of 2 cells, that is potential difference between AC point, which is equal to, so as I said that sum of the potential difference between these 2 cells, sum of the potential difference between this cell and this cell, then you will get the total potential difference between AC point. So according to that, as we got it, this is the expression for this. We got it this. Now you are substituted from the equation 1 and 2. We got separation of variables. We will get it this type of expression. So now you have to consider equivalent EMF circuit. This is an equivalent EMF circuit, is it? This equivalent EMF circuit. So here we are considering single cell whose EMF is E equivalent and internal resistance is R equivalent. So it sends the same amount of current, is it? So you have to find the potential difference across the terminals of what? This cell, I mean equivalent cell. So according to that potential difference across AC point, which is equal to this, from comparing equation 3 and 4, we will get equivalent EMF, which is equal to sum of the EMF of the 2 cell, and equivalent internal resistance, which is equal to sum of the internal resistance of the 2 cells. If you can generalize this expression can also generalize for n number of cells. Say your circuit contains n number of cells. In that case, that expression goes to change. That is E equivalent, which is equal to sum of individual EMF plus En. Similarly, R equivalent is equal to R plus R like this. Rn, you can write it. So now we will proceed for the second parallel grouping of cells. See here, as I said it, first of all, when we are saying that two cells are grouped in parallel, as I said that between two given points, positive terminal all the cells were connected one side, one point, and negative terminal all the cells were connected for the other side. So between two given point, terminals of all the cells, positive and negative, if they are connected between two given points, such a grouping of cells is known as the parallel grouping of cells. According to the definition, parallel grouping of cells. Parallel grouping. See here, what you have to do that? See, these are the 2 points are there. This is, you can say that A point, you can call that. This is the first cell. Its EMF is E1, R1. This is the second cell. Its EMF is E2, internal resistance R2. So you can call that this is the B1 and B2. See here, main current will going to enter, say I ampere of current it enters at the junction B2. So it is going to divide into 2 branches. I1 ampere, it flows along first cell, and I2 it flows along second cell E2. So this is positive, negative, positive, negative. This cell sends the current I1. This cell sends current I2. Once again at this junction, so I1 and I2 together they will meet at the junction and leaves from the junction as main current. This is the main current. This is the, you see that it these are the 2 given points are there. B1 and B2 are the 2 given point. The positive terminal of the 2 cells were connected at one point, B1 point. Negative terminal of the 2 cells were connected second and the B2 point. If there are 3 cells are there, and the positive terminal of the third cell, if it is connected B1 and negative is connected B2, I mean that all the positive and negative terminals, if they are connected between 2 given points, is which is known as the what? Parallel grouping of cells. Is it? So you see that this is what the parallel grouping of cells. The basic purpose of this cell so is to, as I said, that to reduce the current in the circuit. I mean that, say, what is the difference between, you may ask that question like write the difference between parallel and series grouping of cells. One is that on the basis of circuit diagram, on the basis of circuit you can differentiate between series and parallel, and another is that on the basis of expression, is it for series grouping of cells, what is the effective EMF, is it equivalent EMF, and what is the equivalent EMF for parallel combination of cells expression. Similarly, so on the basis of definition for parallel grouping and series grouping, you can write 3-4 difference for the series and parallel grouping of cells. Now we got the clear picture of the when the 2 cells are said to be connected in series and when 2 cells are said to be in parallel. If 2 cells are connected, 2 cells are 2 or more cells, if they are connected between 2 given point, is it? Such a grouping of cell which is known as the parallel grouping of cells. So in this case we are consider 2 cell. This is the first cell whose EMF is E1 and its internal resistance is R1. Second cell, its internal resistance is R2 and EMF is E2. These 2 cells were connected between B1 and B2, between 2 given point. The first cell EMF is E1, first cell current is I1 and second cell current is I2. These two cells current meet at the junction A. So on meeting at the junction A, sum of I1 and I2, you will get the main current. So this is the description of the what parallel grouping of cells. So what you have to that in order to obtain the equivalent EMF of the two cells when these two cells are arranged in the parallel, when these two cells are connected in the parallel grouping. If it is first what you have to do that, so you have to find the potential difference across the across the terminals of the first cell. Similarly, you have to find the potential difference across the terminals of the second cell. So then see, you have to write it potential difference. Step 1, potential difference, PD, potential difference across the terminals of first cell is, so as you know that is potential difference between is equal to, you see that what is that, you see that